I'm going to explain very important part in atomic structure, that is atomic number. Atomic number, its symbol is Z. So this atomic number is actually number of electrons or protons, because in an atom there is no charge, atoms are neutral, so electrons and protons are same. So it may be defined as the number of electrons or protons present in an atom. So atoms are neutral. Atoms do not have any charge. So this is the definition of atomic number. So either electrons or protons. Like in case of sodium, here atomic number is 11. Atomic number is written on the lower side left hand, lower left. Now this atomic number, it is an absolute. It is an absolute quantity. It is an absolute quantity. Means it is never in fraction. That is never in fraction. Never in fraction. It is always fixed. Never in fraction. It is always absolute value 1, 2, 3, 4. Like not 1.2, 1.7 like that. So this is atomic number. Now atomic number is a fundamental property. Next point is it is a fundamental property. It is a fundamental property of atoms, elements. Fundamental property that no two elements, no two atoms, different atoms can have same atomic number. That is, no two elements can have same atomic number. Atomic number cannot be same. So you can imagine the importance of this atomic number. It is so significant. Now coming to an ion. So ions, in case of ions also, we take the electron. So this is very important point. In an ion, the atomic number is equal to its electrons. So that condition we say number of electrons. So it is better to keep in mind number of electrons in any species, whether it is an atom, whether it is an ion, it is the atomic number. Atomic number is never in fraction, it is always in whole number. It is always in whole number. Now, coming to second part, it is atomic mass. Atomic mass. Here the symbol is capital A. Atomic mass. It is also called as atomic weight. Both have same symbol. Symbol is same. Capital A is both whether it is this or this. Now it is defined as the sum of protons and neutrons. Sum of protons and neutrons present in an atom or ion. So they are always same. The protons, neutrons, electrons. They decide any ion or decide any atom. So this is very significant. Now, so this A is equal to P plus N. This is number of protons. This is number of protons. This number of neutrons. And so this is the very important formula to keep in mind. A is equal to P plus N. Now we will correlate, we will relate with the other formula that Z is equal to electron, or Z is equal to proton. So if we correlate, if we compare these two, very simple formula, what we say here, this is not mentioned in this. So, and here electrons and protons, they are same. So a formula which has evolved, that number of neutrons in any species, it is equal to A minus Z. So this is this is the third formula, how we correlate. So this number of neutrons, A, atomic weight minus atomic number. This is very important. Now I'm going to explain something more about the atomic mass. As you know, atomic number is always in whole number. It is always, single for an element, but this is not applied to this. So it may be in fraction. It can be in fraction. It can be in fraction because protons and neutrons, they sometimes they have slight fractional mass. Because proton is very energetic particle, so it keeps on radiating energy. So its value is sometimes in fraction. Second is two different elements can have same atomic weight. This is very important point. So what we can say? That is atomic mass. Atomic mass cannot be a fundamental character. Atomic mass cannot be a fundamental character in an element, because in some cases it is same for two different elements. Like example, in isobars, the atomic weights are same. Now I'm going to explain the representation representation or expressing atomic mass means unit. So unit of A equal to U, small u. Small u is unified mass. So it is SI unit. It is SI unit of atomic mass. It is the SI unit of atomic mass. SI unit of atomic mass. Now, next point is the index. How we write down the atomic number and atomic mass in an element. So here I am taking sodium. Element is there. So here we on the lower left we write the atomic number, and lower and left top we write the atomic weight. So this is atomic mass and this is atomic number. It is fixed throughout the world. Everyone has to follow this. Or in general case, what we say? E is an element, and here is the Z, here is the A. So this is the index of an element with A and Z. So this is atomic mass, atomic number, their representation, their significance. I'm going to explain about the next topic, isobars. So isobars are actually, iso means same, bar means weight. So these are the atoms of different elements having same atomic weight, but atomic number is different. So isobars may be defined. Isobars may be defined as atoms of different elements. Atoms of different elements having the same atomic mass. Atomic mass, atomic weight is same, but different atomic number. Atomic numbers are different, atomic masses are same. So isotopes are very less, rare in number. Isobars like this neon 18, 14, calcium 20, 40. Neon is a noble gas. Calcium is a metal, very reactive metal. See here, electrons are 18, protons are 18. This is atomic number. So it is equal to electrons and protons. Electrons and protons are same in an atom. So 18 will be both. So this is A. So 18, we have to subtract 18 from the 40. So it will be, number of neutrons will be 22. Now in this case, electrons will be equal to 20, photons will be equal to 20, and neutrons will be 40 minus 20. So it comes out to be 20. So this is about the isotopes, and isotopes, they are not so much, as significance, but they are used in the studies. Isobars, they are not so important like the isotopes. They are very limited applications of isobars, and so this is all about isobars.